This talk is a little bit targeted to the early career side of this workshop, and it's really to give you a bit of an insight into my story, so where I came from, where I am now, and in doing that, it really highlights, I suppose, the commercial wheat breeding industry in Australia. So we're a little bit unique in Australia with our wheat breeding, so I'm going to talk a little bit about that as well. And as part of that, I'm going to go into the company that I work for, which is Intergrain. As Kai mentioned, we're a wheat and barley breeding company. And then I'll also give you a little bit of my perspective on some of the skills that I see is needed in a plant breeding context in Australia specifically, as well as some of the pros and cons of being in industry in plant breeding specifically, and yeah, a little bit of my perspective on that as well. So to start with, I'll start with my story. So if it wants to work. All right, so this is just a little bit about me. So Kai gave you a little bit of a brief introduction, but I did do my PhD in academia, and now I've moved through to commercial industry. So I'll take you through that sort of pathway for me. And it all started, I suppose, back when I did my bachelor's degree. And initially when I was in high school, I did not ever think I would be in agriculture or science. I had my heart set on being a lawyer, which is, you know, a bit of a 180 to where I am today. And during this process of going to university and sort of realising what happens in the real world, I sort of started to begin to realise, hey, law's not really for me, and started to rethink where I wanted to go with my career. During this time, I realised that maybe something in health or nutrition would be interesting, so I moved into a role to become a dietitian. Now, little did I really know at this time that that's actually made up of a large amount of science. And at this stage, I hadn't done science since I was 15. So I stopped doing it in high school, which I wouldn't recommend. But as going into this degree, it formed some of my background where I actually fell in love with science. And this is when I decided to fully change into a science degree. At this point, I still didn't know that I had a love for agricultural science. I didn't grow up on a farm or really have much exposure to farming. And it was actually through my experience with CSIRO that I started to really fall in love with plants. Now, CSIRO, for most of you may know, is a large research organisation in Australia that's funded by the Australian government. They're located, so if I can get the laser pointer working. So they're located in Canberra, which is down around here. So at the time I was studying up in Queensland here in Australia. So I had to make the shift down here to do a bit of an internship with them. And during that internship, as I said, I realised that plant science was for me. And I decided to go back to Canberra once I'd finished my degree and completely change pace and do an honours in plant science, specifically in wheat, and looking at some of the major proteins that are involved with the germination process here. So my background initially was a lot in biochemistry, so a lot of protein expression, enzyme activity assays, and at this time I was looking at some mutants of this protein alpha amylase, looking at null mutants across the wheat genomes. So that's when I really first got my experience for research, and it's sort of how I ended up here today. So I do have a lot to thank for, from CSIRO. So after my honours, they did say to me that I could do a PhD with them down in Canberra, but it's pretty cold there, so I did want to go back up to the beaches in Queensland. And I actually did my PhD with Lee Hickey, who you all know very well by now. And I just thought I'd give you a very quick introduction to the Hickey Lab. And there's a lot of members at BGRI today. And this introduction is a little bit dated now, but it's very relevant and accurate for my experience during my PhD, which is, I suppose, what this talk is all about. So we'll see if it works. Oh.
Hi, I'm tolerance in durum wheat.
Hi, I'm Laura. I'm working on leaf rust resistance in barley.
Hi, I'm Wei. I'm working on scrape rust resistance in wheat.
Hi, I'm Hannah. I'm working on root traits in barley.
Hi, I'm Dharmin. I'm working on plant pathogen interaction in wheat.
Hi, I'm Eric. I work on yellow spot disease resistance in wheat.
Hi, I'm Adnan. I'm working on leaf rust resistance in wheat.
Hi, I'm Ming. I'm working on crown rot resistance in barley.
Hi, I'm Amy. I'm working on combining breeding technologies in wheat.
The Hickey Lab conducts discovery and applied research on Australia's most important cereal crops, wheat and barley. We are situated within the Queensland Alliance for Agriculture and Food Innovation, right here at the University of Queensland in Brisbane, Australia. Our research is focused on key abiotic and biotic factors that limit grain production, as well as development of novel breeding tools and methodologies. Our germplasm pipeline takes advantage of large nested association mapping populations, speed breeding technology, high throughput phenotyping methods, and genotyping by sequencing marker platforms. We develop novel pre-breeding germplasm with adapted genetic backgrounds, along with validated marker trait associations. Our genetic studies improve understanding of gene effects, trait interactions, and interactions with specific environments. Such information and tools better equip breeders to assemble improved cultivars for farmers. To stay up to date with our research, visit our website at hickeylab.com or subscribe to our YouTube channel, Hickey Lab.
Now, I swear Lee didn't get me to talk just to do a promo for his lab. But no, it is a bit of relevance to, I suppose, my background. And so as you would have seen from the video, I did my PhD on barley and I looked at the major genes controlling root system architecture and predominantly for drought adaptation. So looking at those genes that control the narrow root systems that grow deeper in the soils that have a high water holding capacity. So what I wanted to briefly do now is go through, just go back, is to go through a little bit about my PhD, so there was 4 main topics of my PhD. But I'm not going to share with you specifically my research outcomes and things like that because this isn't a barley conference, but I wanted to highlight to you some of the techniques that I learnt during my PhD that I found really valuable when I jumped straight into industry. And I thought it was important to highlight these to you. So just quickly jump. So as I mentioned, I worked on barley. Now root traits is a really tricky phenotype to work with. And so Matthew was talking a lot about how hard it is to measure root traits and how we can now use canopy temperature in the field, has a really good correlation. But what we were looking at was this clear pot method, which you can see here. So this clear pot method was one of the high throughput methods we used to look at the seminal root angle in both wheat and barley. So when I talk about seminal root angle, I mean the first pair of roots that emerge relative to the vertical here. So we measured these using these transparent pots. We sowed 24 seeds around the outside of the wall of the pot with the embryo facing down. And this encourages the plant to grow its roots on the edge of the pot. Now, this method has been published by one of my colleagues, and it does work in both wheat and barley. So we put these clear pots into black pots, and then we sow them, or we let them grow in the glass house for about a week. And after a week, when they're at about this growth stage, we take images, and then we use image analysis software to measure these angles. So it's relatively high throughput, really low cost, and it's really quick and easy. And using this method, I was actually able to phenotype 3 different populations during my PhD. I looked at a large double haploid population. I looked at a large actual breeding population from a breeding program. And I also looked at a large NAM or nested association mapping population. All these populations were really large. And by using this method, it was the only way that I could quickly phenotype them and use something that such as seminal root angle, as a proxy for the mature root system architecture. So using this method, I'll just go back, I was able to perform a lot of different analyses. So this is just one example of some of the results from the double haploid linkage analysis, and identify a number of key QTLs, especially one major one that did explain a decent amount of the variation in barley. So this is just an example of how using high throughput phenotyping to map some of these genes that then can be validated and used by breeders is a really important technique. So another part of my PhD was actually validating whether roots were contributing to yield in barley in actual breeding trials or breeding yield trials across Queensland in Australia. So this is Australia, and this is the area that the breeding program was breeding for, which is southern Queensland and northern New South Wales. We had yield data from 20 different environments across 3 years. And what we did was we looked at the genetic correlation between these environments and what we were looking at in the glasshouse, measuring these seminal root traits. Now, how we did that, and this is one of the key techniques that I've been able to take with me to the breeding company, is we did a multi-environment trial analysis, or a meta-analysis. And it's becoming more and more common that breeders are doing these forms of statistical analysis by themselves, or they have a very strong understanding of these analyses, in Australia I'm referring to, and are able to really understand some of the outcomes of these analyses. So what a meta-analysis does is basically takes into all the spatial variation that happens in each of these field sites, combines it into one large model, and then it ranks the genotypes within each of these field trials. So it predicts genotypes that weren't there, ranks one, and puts it all together, and then ranks the environments based on the clusters the environments based on the genotype rankings that are similar across environments. So it puts them into clusters. So I had 20 different environments, and you can see they've clustered into 4 different clusters, and you can see a lot of them are clustering into this one main one here. So this is about sort of trying to understand a bit more of the G by E with some of the yield trials we were looking at. But again, we're able to then build roots into this model and do some genetic correlations across these trials. So my main point here is not what we found with the correlations, but just how important some of these statistical analyses that you may be doing currently in your PhD or in your postdoc, and how directly applicable they are to a breeding program. So I was actually able to walk in and help the breeder do their yield analysis straight away. So that was a huge thing for me, and it was huge value for the breeding company that I went to. So another huge, I suppose, experience for me was running field trials. So during my PhD, I ran 5 yield trials across 2 years. And basically, with the help of Lee, I was predominantly responsible for them, and I had to do everything from the seed prep, the seed packing. I had to sit on the back of the tractor and sow it, take all the field data, collate that data, analyze that data, harvest the field, everything basically. And that was really, really good experience, because that's actually what happens in a breeding program. And yes, when you get to the commercial program, you have technicians doing that for you most of the time in terms of the seed packing and things like that. But it's really good to have a perspective and an understanding of what they're going through so that you can assist them with their job as well. So this was just, and Matthew's spoken a lot already about NDVI. So I was just measuring NDVI in the field and looking at the genetic correlation with root traits. So we were looking at both above and below ground drought adaptation. So we weren't using a very high throughput technique. We were using a green seeker, which takes a very long time when you're walking about 1,200 plots. But basically, we were measuring the near infrared reflectance, which you can see is from a diagram down here, that it changes depending on the health of the leaf or the stage, the growth stage. So this is again just another example of how important it is to be involved in some of this field work for future and moving into commercial breeding. So with this data, I actually in the field I had a number of populations. I had a large double haploid population and a subset of a nested association mapping population. On the PowerPoint here, it's not really clear, but we were able to combine the QTL that were identified across populations and project them onto this one consensus map. And we put together roots and stay green, and we found a number of co-locations with the different stay green traits that we did model. But again, just another example of how these techniques are highly relevant to breeding as well. Now, the final part of my PhD was looking at the relationship between roots and flowering time in both wheat and barley. Now, we used a number of techniques in this study where we initially found this association. I'm not going to go into it now because I am giving a talk tomorrow in the BGRI, so you'll just have to wait till then. But again, it was just another experience that did add to, I suppose, my portfolio for going into commercial breeding. So where am I now? So I mentioned I'm now at a commercial wheat and barley breeding program. We're called Intergrain, and I'll give you a little bit more information about the company in a couple of minutes. But my role in Intergrain is a little bit different. I'm not a breeder, right? I want to be a breeder one day, but I'm not a breeder right now. My role is to manage their research and development projects. So Intergrain currently at the moment has about 18 R&D portfolios. So we invest with the pre-breeders in Australia, so it's a bit of a different model. We have an organisation called GRDC, who is government owned but is subsidised by farmers' levies. They invest in R&D projects, and often we co-invest with them, or we will invest as well just by ourselves with pre-breeders. So my job across both wheat and barley is to manage these R&D projects, identify new R&D projects that's going to help our breeders, and really be that interface between the pre-breeder and the breeder. And it's really important that we have someone in this role to make sure that that technology transfer does actually happen. So I'll go into a little bit more detail in a couple of moments about some of our research projects, but that's basically my role at the moment. So before I do that, I thought I'd tell you a little bit about breeding in Australia, because it is a little bit unique compared to some of the other countries. So wheat breeding in Australia, it's basically all commercialised now. So about 20 years or so ago, we did have state governments, so our government in each different area in Australia was breeding for a specific area of Australia. But now it has commercialised. Most of the commercial companies are still relatively government owned, but it's all more now very competitive. So all the plant breeding and specifically the wheat and barley breeding companies in Australia are nationally focused. So they're breeding for the whole of Australia, not just one small area. And that's really tricky for Australia because we have some really, really diverse environments, from our weather conditions to our different soil types. Now, most of our plant breeding companies in Australia have international connections. So this is really important for international germplasm transfer. So what I mean by international connections is generally they might have a small proportion of the company that's owned by another international company, or they have a contract in place for some of this germplasm exchange. Also, most of the companies have a multi-crop approach, and because of the commercial nature of plant breeding in Australia, there's a lot of push and drive for putting some of these new technologies into our breeding strategies. So new technologies that you've heard a lot about today, so technologies such as genomic selection, high throughput phenotyping. Now, I've said it a number of times already, but it's a very competitive market, but we have a strong grower focus because our growers are really engaged in a lot of the pre-breeding and the research work, which filters down into our breeding companies. And also, the growers do have quite a lot of, I suppose, power in Australia because we have this endpoint royalty system. And this is quite different to a lot of the systems, especially in the US. So endpoint royalties is about where the farmer actually pays the royalty to the plant breeding company. So when the farmer at the beginning of the season goes to buy their seed, they do not pay the royalty there. all they're paying for when they buy that seed at that time is basically any of the seed shed costs. So any costs to store or maintain that seed that's come originally from the plant breeding company. So the grower will then take that seed and they'll grow it for the season, and what they end up with and what they decide to sell back to the grain traders, that's where they pay their royalty. So this sort of strategy of endpoint royalties is really about sharing the risk, and it puts more ownership back onto the plant breeding company, which again is driving these new technologies coming into breeding. Because if you release a really bad variety that doesn't yield well, you're not getting that money because you're not getting your royalties. You're getting your royalties based on your farmer's yield. So it's pushing the plant breeding companies again to be more competitive. And also, farmers won't grow it, to be honest. We have a lot of things in place, and I'll talk about them in a moment, where farmers get a lot of information about how the varieties are yielding in Australia. So they won't grow it if it's not yielding well in their area of Australia as well. We also have this, and we encourage the commercial breeding companies, farmer-to-farmer trading. So this is where farmers can sell the seed across the fence as well. But this farmer-to-farmer trading, it's really important that farmers are good with talking to us about that as well, because again, that influences on when the royalties come back in. So there's a number of breeding companies in Australia at the moment that are working on wheat. So as you can see, Intergrain's up there. We also have a major player, AGT. So AGT currently for wheat has the market share in hard wheats grown in Australia. So probably about 70% of the wheat grown in Australia is AGT varieties. And then we have a few other players as well at this stage. Intergrain doesn't have such a great market position in hard wheat at the moment. We are the lead udon noodle breeding company, and we also do have the market share in barley in Australia. So I'm sure, and I hope you've seen this, or everyone's well aware of what a general breeding strategy is and how long it takes. So Matthew spoke this morning about breeding can take anywhere from 10 to 30 years, depending on the company. But generally it's between 10 and 12 years to go from crossing to releasing a variety into the farmer's paddock. And it's just too long. It really is. And that's where we've really got to get these new technologies into breeding, because we need to, especially in these early stages, be able to quicken up the process or fasten it so we can increase our genetic gain and get better yields for our farmers. Now, as I was mentioning before, in terms of Australian farmers, they actually get to see a lot of what goes on in terms of the yield for the different varieties, and they get to see that for a number of years. So we have this thing called NVT in Australia, and that happens at the end of the breeding cycle. So NVT stands for National Variety Testing or Trialling. Basically what happens is that the Australian government pays for they pay for NVT, or they own NVT, to go out and put all the plant breeding companies' lines all across Australia, and they yield test them, and they measure a few different traits, but predominantly it's about the yield. And then they do analysis to try and understand what's going on with all the different environments. And this NVT is so important for farmers. They really make a lot of the decisions about what variety that they're going to grow based on this trialling system. So it highlights that there's not a whole lot we can do about quickening up this, increasing the speed of these later generations. So we really have to try and focus on this area. Well, that's specifically how Intergrain feels. This is how we're going to make our genetic gain, by basically halving here. So speaking of Intergrain, I just want to give you a little bit of background, and this is Intergrain, but it's probably a relatively good example of most of the breeding companies in Australia, a bit of how they operate.
Intergrain is an Australian wheat and barley breeding business. We develop new varieties for Australian growers that have improved yield, better disease resistance, and deliver the end product customer requirements.
We begin the new genetics, we innovate new products and see them right the way through that process to delivering them to customers in other countries.
Intergrain has a specialty program in wheat breeding, and that is our udon noodle program, and that is where we are targeting a specific grain that has led to Western Australia being the world exclusive supplier to Japan and Korea for grain of udon noodles.
I think you'll find that everyone that works at Intergrain is a very proud member of that food chain. At the back of our mind is always that importance of food security, of production for the countries that aren't able to produce enough for themselves.
So that's just a very brief snapshot of Intergrain and specifically our wheat breeding program. And we do focus a lot on our udon breeding as our specialty. So a bit of background into Intergrain. So our major shareholder is Western Australia, the Government of Western Australia, because that's where we're based, and also GRDC, which I mentioned is an Australian-owned organisation, a government-owned organisation. So you would have just seen our CEO is Tress Walmsley, so she was just on that video. She's been with Intergrain since the beginning of our inception, and she's had an integral role in a lot of these strategies involving commercialising the breeding sector in Australia, as well as introducing this endpoint royalty system, which I believe really does drive a lot of the competitiveness of plant breeding. So onto our wheat breeding program specifically. So Dr. Dan Mullen is our senior wheat breeder at Intergrain. So he's been with Intergrain for the last 8 years, and he's basically been there from the beginning. So he's had past experience at CIMMET, so he worked directly under Matthew in the wheat physiology department, and also had a background at CSIRO and with the University of Western Australia. Also a little bit about our barley program. Our head barley breeder is David Moody. And as I mentioned earlier, Intergrain is the market share leader for barley production, or barley varieties, sorry, in Australia, with over 50% sown to our varieties. So this is just, and this really highlights typically what happens in a commercial breeding company in Australia. All of these little yellow dots, orange dots, sorry, those are all of our trial sites just for 1 year. So that's where we're trialling, and that's not including those national variety trials. This is the ones that we are paying for, the ones that we are managing, the ones that those senior breeders are walking every plot in those trials. So that just gives you a scope of nationally breeding in Australia, and you have to have those to be able to really get an understanding of the different environments, because the environment over here in Western Australia is so different to what's going on up here in Queensland in terms of rainfall. So in WA, we have a winter dominant rainfall, but up here in Queensland, they have a summer dominant rainfall. So that means completely different things on what type of soil moisture you're sowing into. Also, our soils over here in WA are sandy soils, whereas over here in Queensland, they have very heavy clay soils with a high water holding capacity. So again, and it brings back a lot to what Matthew was saying earlier this morning, environment is huge, not only for selecting your traits, but for your breeding as well. Oh, I should also say for Intergrain's sake. So we have, so this is all the breeding trials we have. We are based here in Perth, and that's where our head office is, but we also do have an office over here in Victoria as well. So you've heard most of this already before, but we are the most extensive udon breeding program in the world at this stage. We do have a very competitive hard wheat market in Australia, and we are not really in that as such at the moment as opposed to AGT, but we do have some promising material in the pipeline, and I think a lot of that's got to do with, at Intergrain, we have a really strong focus on our R&D relationships and pre-breeding. So I'm going to talk a little bit about that now. So this is where my role at Intergrain comes into, and this is about some of our research and development programs that we're actively engaged in. So as I mentioned before, we have about 18 to 20 different research projects on our portfolio that we're investing with and that we're engaging with. So here's just a couple of examples, because I couldn't show you all, and some of them unfortunately are commercial in confidence. these ones aren't though, so you're okay. But so this is a really large research and development program that we're involved in, and you can see that there's a number of different organisations in Australia that are involved in this project. We've got the University of Adelaide that actually leads the project. There's a number of other universities and a number of breeding programs that also co-invest. So in terms of when I say that we're investing in breeding program and pre-breeding, we may invest in kind by running a lot of their material in our field trials, or we may actually give them money as well. So it just depends on the specific research project. So this project is focused on improving wheat for a hot and dry climate, specifically in Australia. It's made up of predominantly 4 different programs, and this project runs for about 5 years. I think it's about halfway through at the moment. So what I've done here is I've just very briefly outlined the main projects, but also what, as a breeding company, we aim to get from these programs. So as a breeding company engaging in pre-breeding research, we sort of need some tangible outcomes and we need some return on investment. So the first program in this larger research project looks at identifying new sources of drought and heat tolerance through identifying some key QTL and validating QTL that have been previously found. And they're validating both the new and the old QTL through looking at the QTL across different germplasm backgrounds as well as in different environments. And what that enables them to do is develop these breeder-ready molecular markers. So molecular markers for these key QTL that have been adequately validated and that can be immediately used in marker-assisted selection. They're also developing a lot of germplasm. So it's about taking some of these more wild germplasm pools from land races and things like that and putting them into an adapted background that we as breeders can use as parents. So they will deliver to us a set of lines that has XYZ different genomic regions that influence heat and drought, but put them into something that we can use, because we can't use a land race as a parent in a breeding program. It's too unadapted and it would probably ruin our program. Also, they're developing a lot of high throughput phenotyping tools. So mainly through remote sensing, specifically for heat and drought. And as part of this development of these high throughput phenotyping tools is the idea that they're actually delivering the technology to breeding companies. So if breeding companies don't already, or the ones involved, don't already implement drones in their programs, they're training them to some extent, but they're also releasing these models that assist in taking that photo and turning it into data. And finally, the last part of this project is looking at the relationship between yield and grain protein. So generally, as you increase yield, you generally find that you decrease your protein content. Now, in Australia, you want a higher protein content so that you can get a better quality rating and get more grain when you do deliver it to the market. So this part of the project is really about trying to investigate the genetics, but also the physiological mechanisms that's going on here, and again, trying to develop these breeder-ready molecular markers. So that's just an example of one of the large projects that we're involved in. Another one, as you can see, has a lot of collaborators on it, looks at the relationship, again, with yield and end-use quality in wheat. So looking at the nitrogen use efficiency and the nitrogen dilution effect. So again, it's looking at some of the genetics driving these traits in wheat and trying to understand more what's going on and identify the key genes that then they can deliver to us. So this project's coming towards the end, and it might be an example as well where you don't always get as much as what you expect out of your pre-breeding projects, unfortunately. But at this stage, we have been delivered some key molecular markers for some key genes. So that is quite promising. So those were just 2 examples of some of the wheat breeding projects we're involved in, and how you can see now what they find in the pre-breeding can be directly delivered to the breeding project. Here are some of the areas that we are currently investing in or are on our way to investing in within Intergrain. So, and it's quite representative of what we believe a number of breeding programs in Australia are doing. So a lot of them have already implemented or are implementing genomic selection in their wheat breeding program at some degree or some level. They are also, a lot of them are using these high throughput phenotyping platforms. If they're not already using them, they're generally collaborating on larger projects with them so that they can implement them into their breeding program. And with these two technologies, and I'm sure Trevor would have spoke about it yesterday, comes big data. And how do we manage this data? So we're also looking into different ways to manage that data and how best we can, what best platforms can make that efficient for us. And finally, when we talked about that breeding cycle potentially being 12 years, we're now looking at alternative niche breeding strategies. So these won't be the breeding strategies that we use in our main programs, but looking at some R&D projects of whether these niche breeding strategies potentially could work for us as well. So that's just a bit of a taste of some of the research that we're doing in Intergrain and some of the things that I am managing. But Lee did want me to touch on what a career in breeding looks like, and from my perspective, as someone very early in my career, what I feel you need to move into the commercial industry in a breeding role. So please keep in mind this is just my perspective, and there's no way that I could give you a list and say this is what you need to be a breeder in Australia or anything like that. But this is just, I suppose, what I've picked up on from my time so far in industry. So you really need to be an all-rounder. So we've talked about a whole different number of things already in this just half day, but Ravi mentioned a breeder doesn't just focus on one trait. They have to think of all the traits and all the potential genes going on. But you have to think, so yeah, you just have to be an all-rounder and be able to think about all those different things as well. We've also, Ravi also touched on the fact that we're not at the point where you can stop walking the plots. And you're always going to have to walk the plots, in my opinion, to some extent. But you do need to couple this with, I suppose, the new technologies that are coming through. So in my eyes, it's a combination of having that love for fieldwork and coupling it with the new technologies that are coming through. So things like the genomic selection, speed breeding, high throughput phenotyping. Also, this is very much an Australian perspective, but we have a really, really high importance of end-use quality. So if your variety doesn't make the quality classification, it's out. We're cutting it. Doesn't matter if it's the best yielding, because the farmer won't grow it because they don't get enough return. So quality is one of the kings. It's yield and quality for us in our breeding program. So it's really important to have an appreciation of quality. And also, I suppose one of the research things for us as well is looking at how we can start looking at quality a lot earlier as well. And I've touched on this a little bit briefly, and I don't know if I'm a bit biased when I talk about this, but I feel that you do need to have a strong understanding of statistics or some really strong support in your breeding program for statistics, because in Australia specifically, we are moving towards breeders doing a lot of their own statistics or having a really good understanding of how things are all affecting each other in their yield trials. So I do know for Intergrain specifically, our breeders run their multi-environment trial analyses. They do that all themselves. We could outsource it, but they have a lot better understanding, and also they know what the statistics is telling them, but also what the field is telling them. So they know if that field was frosted, so then they can put that into their understanding as well when they're looking at their overall yield clustering as well. And another important thing that we might not always think about is, what about the research in statistics? We sort of need to, I think as a breeder, it's important to be looking at what's coming through statistically and what we can implement into our programs. This is basically just my story, and I always feel that if you follow this and you always do something that you're passionate about, you'll always probably end up in the right place anyway. So thank you.